In this video, we're going to talk about parallel lines and proportional parts. So the theorem that we're mainly going to talk about here is the Triangle Proportionality Theorem. It says if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the sides into segments of proportional lengths. So here's a quick picture to show you what this is trying to say. So here we have a picture, and we've got some information that's being given to us. So the first part of this theorem, it says if a line is parallel to one side of a triangle, that's talking about this line right here, EB. Okay? It's parallel to a side, DC, of this triangle. Okay? So that's the first part of that. The other part is it intersects the other two sides. What it means is that it touches at E and B. Okay? It needs to go all the way through the triangle. Otherwise, this does not fit exactly into the theorem, and it may or may not work. Okay? So if this happens, then it divides the sides into segments of proportional length. In other words, this is what it's saying. If I compare AE, okay, that longer side of the left-hand side, to its smaller part, ED, okay, then they will be proportional. So it's going to be equal to AB over BC. And this is really going to come in handy for trying to prove different things that are parallel, to determine if things are similar, because it's going to skip a lot of that middle stuff. Like in the previous section, we learned about side, side, side similarity and side angle side. This kind of just goes right through the door as long as you've got those parallel parts. So it's pretty handy. Okay, so here's our first example. It says in triangle DEF, EH is equal to 3, HF is equal to 9, and DG is 1/3 the length of GF. Is DE parallel to GH? So let's first of all go ahead and label everything in our picture. So EH is 3, that's this little side here. HF is 9. And DG, so this part right here, is equal to 1/3 the length of GF. Okay, so we have a few things to work with, okay, but it's going to be kind of difficult to figure out what DG and GF's lengths actually are. So we're going to take our time and get this started. So what we're going to do next is make sure, oops, I don't want to erase, is make sure that we label our side GF as something as well. And since we have no idea what it is, we're just going to leave it as GF. So we're going to follow our theorem and set up a proportion. Even though there's a lot of missing items here, it's enough. So what I'm going to do first is compare the sides that I know. I'm going to do EH, which is 3, to HF, which is 9. So I'm going to do 3 over 9. And then equals, and I'm going to find the corresponding parts. So the small side of this DF side is the DG, which is equal to 1/3 of GF. Okay, and then the next larger side is just GF, whatever it may be. So GF is kind of like acting as our X, if you will. So we're going to cross multiply to solve, and when we do that, the first cross product I get is 3 times GF, and that's going to equal 9 times 1/3. Well, what's 1/3 of 9? It's 3. 3GF. Now, granted, we don't have an actual number here, but if the proportion is true, then this side should be the same as this side, which it is. Okay? So since they're equal to the same exact thing, these sides are proportional. So we've got that checked off. So what that theorem said is that if you have all these proportional sides, then you must have parallel lines in here. So if the parallel side is going to be DE and the parallel line is going to be GH. So the question is DE parallel to GH? And we're going to say, yes, it is. Okay, so as long as those sides are proportional, you have parallel lines present. Okay, so our next theorem is the Triangle Midsegment Theorem, and it states that a midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So again, I'm going to draw a picture for you to describe this. So here's a picture of a triangle with a midsegment, and keep in mind that the midsegment that we're talking about is JK, okay, and it's splitting the sides into 2 equal parts. So K on this side of HG, this point is a midpoint, which means that this side, okay, and this side are the same length. And the same goes for J. J is a midpoint as well, so this side is congruent to this side. We know that information right off the bat if we know that JK is a midsegment. Okay, so what that means is that if I know the length of JK, okay, let's say it's 5. Okay, its length is 1/2 the length of the side that it's parallel to. This right here is the side that it's parallel to. So if 5 is 1/2 that length, then FG must be twice as big as the midsegment, which is 10. So that's all that theorem says. Okay, so here's our next example that's going to use that theorem. It says in the figure, XY and XZ are midsegments of triangle RST and find each measure. So first of all, this is the picture that it gives us, and then we're going to try to find 3 different parts of this triangle. So the first question is to find the length of XZ. Now, XZ, we were told, is a midsegment, which means that whatever side XZ, and I'll put that in orange, whatever that side is parallel to, okay, then XZ should be 1/2 of its length. And the side that it's parallel to is RT, right down here at the bottom. If RT is 13, we're going to divide that by 2, and we will have the length of XZ. So 13 divided by 2 is equal to 6.5. And since we know that information, I'm going to go ahead and put that in my picture, just so that I have it. The next part, part B, is to find the length of ST. Now, ST is this side in green, okay? We don't know what its length is, but we do know that it is parallel to the midsegment, XY, okay? So the midsegment has a length of 7, which means ST must be double its length, which means that this length is going to be whatever 7 times 2 is, which is 14. And then label that in my picture as well so that I have it. Okay, and then the last part is going to be for us to determine the measure of angle RYX. And I'm going to highlight this one in black. RYX is this angle right here. Okay. Now, you may be wondering, how on earth am I supposed to find an angle in here when all I know are sides? Well, the thing is we have an angle in here as well, which is 124 degrees. So here's the tricky thing in this picture. The side of XZ and the side of RT are parallel, okay? Which means that I actually have alternate interior angles. One of them being 124 degrees, and its alternate interior angle would be this one right here. And alternate interior angles are congruent, which means that this must also be 124 degrees. Just like that. And that will conclude this tutorial.